insertion sort algorithm, we have the following steps to sort an unsorted array. First of all, we start with dividing the array into sorted and unsorted subarrays. First element is the only element in the sorted section, the rest is unsorted. That's why we start iterating from the second element. Then we copy the current element in another variable so it doesn't get overwritten. After that, we compare the item in the index previous to the current item. So if the previous value is bigger than the current item, we shift the previous value to the current position. Finally, we decrease the value of iteration until we get to the index 0. Let's see an illustration to understand this concept visually. In this example array, the value 3 at index 1 is already sorted. So we start sorting the next value, which is 5. The value 3 is less than 5, so 5 stays in the same place. Next value to be sorted correctly is 1. It is currently in third place. The value 5 is greater than 1, so 5 is shifted to third position. Then we analyze if 1 is bigger than 3. No, it's not, so 3 stays in the second position. Next we verify and insert 1 in the first position. So far, the first 3 values are sorted. The next value is 4. The value 4 is less than value 5, so it gets shifted to index 3. Next we compare 4 with 3. Value 4, which is in index 2, is greater than the value 3 in index 1, so value 4 stays in index 2. Last value to be inserted is at index 4. 5 is greater than 2, so 5 gets shifted to index 3. Value 4 is greater than the value 2, so 4 is shifted to index 3. Next value is 3, which is greater than the value 2, so value 3 is shifted to index 2. Finally, we compare 2 and 1. Value 2 is greater than the value 1, so value 2 is inserted at the second position. Consequently, we sorted the whole array. As usual, we are declaring a function which accepts an unsorted array. Next, we are running a for loop, which starts from the second element to the end of the array. Then we are declaring a variable which will hold the current item being iterated. We are also declaring variable j as one index less than the current. And then in a while loop, we are comparing the current index with its adjacent element. If it's bigger, we shift it to the current position and decrease the value of j. At the end, we will insert the value in its correct position and return the array. Now the time complexity. For the iteration, we are reading one item at a time, so it's O of n operation for both the best and the worst case. And to shift the items, and if the items are already in the correct place, we don't do anything, so it will be O of 1 operation. For the worst case scenario, the array is in descending order. We need to shift all the items to the right of current item. That's an O of n operation as well. So the total time complexity of insertion sort for the best case scenario is O of n or linear, or O of n square or quadratic for the worst case scenario.